Hello everyone. So this is our second lecture in the complex lecture series for DCN, and today we'll be covering the concept of subnetting. So in the last class we had covered the concept of IP addressing. So this subnetting is used to divide a large network into smaller subnetworks. So let's say there is a big network and now we want to break this network into 4 subnetworks. This is one large network and we want to break it at subnetwork 1, subnetwork 2, similarly subnetwork 3 and subnetwork 4. So this concept is known as subnetting. Okay. So it helps in improving the network management and security. It allows efficient IP addressing usage. And how is it done? It is the most important thing. And it is accomplished by borrowing some portions from the host part. So we are aware that in class A, there are 8 bits for network and 24 bits for host. So if a class A network has to be divided, then I have to borrow few bits from the host. That means from these 24 bits, I will be using some bits depending on how many networks I want to create, how many sub networks I want to create. Similarly, in class B, there are 2 raised to power 8, 2 raised to power 16. Rather than mentioning in 2 raised to power form, let's write 16 bits and 16 bits. 16 bits for network and 16 bits for host. So if you want to create a subnetwork or multiple subnetworks in class B type network, then we have to borrow some bits from this 16 bits of host. Similarly for class C, there will be 24 bits in the network and 8 bits in the host. So if you want to break a network of class C type, then we have to borrow some bits from these 8 bits of the host. Okay, so this is the strategy which we are going to use. That is a borrowing strategy for creating the subnetworks. Okay, so this is the strategy. First, determine the network requirements, number of required subnets and number of hosts per subnet. That means having the complete specification to we are going to break this large network into, let's say, 4 subnetworks, and each subnetwork will be having that many number of hosts. Okay, let's say 1000 hosts in each subnetwork. So we will be provided with an IP address and we will be told that break this network into 4 subnetworks and each subnetwork must be having 1000 hosts, something like this. So this is the part of the specification. Then we have to choose the subnet mask. Choose the subnet mask means for class A, we are already aware what is the mask for class A, 255.0.0.0, and class B mask is 255.255.0.0, and for class C mask is 255.255.255.0. But these are the default masks. But to create subnetworks in the network, we will be using bits from these hosts part which are shown 0 in these IPs, in these networks. So that means from the default mask, I will be requiring a customized subnet mask depending on what is being provided to me as a requirement. How many networks are required, how many hosts are required inside the each network. Depending on this, I'll be creating a customized subnet mask. That means an updated mask will be prepared, and from that updated mask, we'll be converting that network into subnetworks. Then calculating the subnet info. So let's say we decide that if we want to create that many subnetworks, then I need to borrow n number of bits from the host part. Let's say if I want to create 2 raised to power n subnets, where n is the number of borrowed bits. That means if I borrow n bits from the host part, I can create 2 raised to power n subnetworks. That means if I borrow 1 bit from host, then I can create 2 subnetworks. How? If, then in that case, this borrowed bit can be 0, this borrowed bit can be 1. So I can simply name it as subnetwork 0, subnetwork 1. Okay. Similarly, if I borrow 2 bits, then 0, 0, 0, 1, 1, 0, 1, 1. These are the 4 possibilities. Then I can break the complete network into 4 parts, 4 subnetworks. So this is how I am going to borrow from the host part to create subnets as per my requirement. Okay. Then, okay, this is also left, number of hosts per subnet. Now, number of hosts will be remaining host bits. So, in a class B, let's say class B, there are 16 host bits. Okay, 16 host bits are there. 2 are borrowed. So remaining are 14. So that means 2 raised to power 14 hosts can be there. Okay, this is how we can control the number of hosts and number of subnetworks inside a bigger network. Okay. So assigning the ranges. So if this is the network 192.168.1.0/24 means there are 24 ones. Or from 192, we can also see that 192 belongs to class C type. Class C type means again 255, 255, 255. Again, that means 8 ones. That means 24 ones. So this 192.168.1.0/24, either we write this or we write class C. This is one and the same thing. And now if we want to create this 26, if I mention it 26, that means I have borrowed 2 bits from host part. Okay. So 24 were already there with the network. These 24 bits already belong to the network. And from the remaining 8 bits, I have used 2 more bits. So these 2 more bits are again, they also become part of the network. Or we can say simply part of the subnetwork. Subnetwork is part of the network. So these 2 bits can be 0, 0, 0, 1, 1, 0, 1, 1. So there can be 4 subnetworks inside this network. And how many remaining bits are there? 6 remaining bits are there. So 2 raised to power 64. That means 64 hosts can be there in all these subnetworks. Okay. So this is the basic. Now we can start with some questions. So we are provided with this network. Network address is provided to us. We can simply see it from this 192 that it is belonging to class C, where the default subnet mask is this. Okay. Now, so class C, it belongs to class C, and this is the default subnet mask. Now we have to create a modified, or which we have mentioned, customized subnet mask to make 14 usable subnets. So by mentioning here usable subnet means, because we know that 2 networks are unusable, all zeros and all ones, because this is network itself and this is for broadcast. So if you want 14 usable subnets, that means definitely plus 2. Which 2? All zeros and all ones. These must be there. Okay. So there will be 16 nets in total, and out of these two won't be used. So there will be total of 14 nets, subnets, which can be used. Similarly, number of usable hosts, again 14. Again, we are very much clear that plus 2, because again all zeros and all ones can't be used. So again 14 can be the usable number of hosts. So total number of subnets 16, out of which we will use 14. 2 avoided. Which ones? All zeros, all ones. Similarly, number of host addresses, again 16. Here it is 14. Again, because we have 2 avoided. Which one? All zeros and all ones. And to do this, to create 16 subnetworks, 16 subnetwork means 2 raised to power 4. That means 4 bits to be borrowed. Okay. And if 4 bits are to be borrowed, then from this 0 part, these are going to be borrowed because it is a class C. Class C, this is the only host part in class C, and this is the network part. I cannot touch the network part to create subnets. So from this host part, which is having these 4 bits which are being borrowed and 4 bits which are being left. So mentioning the weights on it, 1, 2, 4, 8, 16, 32, 64, 128. So 128 plus 64 plus 32 plus 16. 128 plus 64 plus 32 plus 16. So if you add all these, it becomes 240. Okay. So that's why this is the custom subnet mask. So if you want to achieve these requirements to create 14 usable subnets out of total 16 created ones and 14 hosts out of total 16 hosts, we have to borrow 4 bits. And if we are going to borrow 4 bits from this host part, then the subnet mask gets changed into 240. Why? Because having 4 bits in the host part, that means 1111, which is corresponding to these 4 weights, 16 plus 32 plus 64 plus 128, which becomes 240. Okay. So this is how we calculate the subnet mask. So this is 192.10.10. We cannot touch it. They are separated, and these 4 bits are borrowed. 128 plus 64 plus 32 plus 16, which is 240. Okay, and these are the 4 bits for the host. Total number of hosts 16 can be there, minus 2, removing the prohibited ones. That means all zeros and all ones. Similarly, for these 4 bits borrowed from the network part, there can be 16 subnetworks, minus 2, again prohibited ones, all zeros and all ones. So 14 subnets can be there. Similarly, we can create subnets in an IP address or a network of any class. So again, taking a situation, let's say this is the IP. From this, I can see that it is belonging to class B. So class B, which is the default subnet mask, this is the default subnet mask, because 16 bits are for the network and 16 bits are for the host. Okay. Now, if we want to create 1000 subnet masks, 1000 subnet masks means, let's say 2 raised to power 10, because in less than 10 number of bits, I won't be able to create 1000 subnetworks. So 2 raised to power 10 is equivalent to 1024. So 1024, out of these 1024, I will use 1000. Okay. And number of usable hosts 60. So 16 out of these 16 bits of host, 10 bits are borrowed for creating subnets. Okay. So how this 192 is appearing here? For that, we have to break it up. So this is 165, 100. We are not going to change the network part, but this 00, we are going to borrow 10 bits from here. So 165, 100, we are not going to change it. And then 10 bits, these 8 bits from the 8-bit segment, and the last 8-bit segment, 2 more bits from here. So if we check here, 1, 2, 4, 8, 16, 32. So 64 and 128 from here. Okay. And 64 plus 128, this becomes 192. And this complete thing is going to be part of the network now. So considering all these bits, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, all 8 bits, they add up to 255. So 165.100.255 from the third part, and 128 plus 64, that means 192 from the fourth part. And after that, these 6 bits are left. So 2 raised to power 6, that means 64 hosts can be there and 2 of them cannot be used. So 62 hosts can be used. Similarly, we have borrowed 10 bits. So 10 bits means 2 raised to power 10, that means 1024 subnetworks are created. 2 of them cannot be used. Again, the same reason, all zeros and all ones, they cannot be used. So we are left with 1022 subnetworks. Okay. So in this way, we can create multiple subnetworks inside a larger network. So there is another question in this. Class is not mentioned, but this is 26 is mentioned. So by 26, we mean that class B means, again, this is the default mask, 255.255 are there. 26 means it is a class B address. Class B address means 16 network and 16 host. But 26 means 16 plus 10 from here, and we are left with 6 host bits. So 16 plus 10, that means again 26 network bits. Okay, so this 26 means this. So 8 plus 2, 10 bits are taken from here. So again, similar to the previous question, the default subnet mask gets changed to 192, and rest of the things are exactly same. If I'm going to use this subnet mask will result in this 192. That means again exactly similar question as mentioned here. The only thing is here the network was 165.100 and here the network is 148.75. The only thing is this, only change is this much. Now determine the range of subnetted networks. So if we are asked to create subnetwork in this network, 14 usable subnetworks. So first of all, looking at this 192, I can see that it is class C. Okay. Default mask is 255.255.255.0. But to create 14 usable subnets, that means 2 raised to power 4, 16 total subnets can be there, out of which 14 usable subnets can be there. That means 4 bits are to be borrowed. 4 bits are to be borrowed from this host part. So the custom mask becomes 255.255.255 dot 4 bits from here and remaining 4 for the. So this 1, 2, 4 and 8 will be used here. 16, 32, 64 and 128. So 128 plus 64 plus 32 plus 16. So this becomes 240. So the custom mask becomes 255.255.255.240. So this is the custom mask. This is how we can create a custom mask from the given specification. And once the custom mask is created, then we have to simply change the values of these 4 bits. These 4 bits can vary from 0000 to 1111. That means 16 possible from here, 0000 to 1111. 16 possible hosts can be accommodated. But again 16 possible hai. 16 minus 2, 14 will be usable. Similarly here, 16 minus 2, 14 usable. Okay, this is a basic calculation. And this is the exact, this is the default mask, this is the updated mask, because we have stolen 4 bits from the host part, and these 4 parts are for the host. Now, leaving the host part, because this is the host part, host, and again host. This network can change from 0000000100100100011 and so on. So if we see it carefully, then 1, 2, 4, 8. These 8 weights are not going to be used. 16, 32, 64, 128. Okay. So 128 plus 64 plus 32 plus 16, we will be getting 240. Okay. So this becomes first subnetwork will be having the address 192.168.254.240, but this 240 is having all zeros, so it won't be usable. Network is there, but it won't be usable. The next network will be this one. 192.168.254 plus 2. Then this one will become 240. Dot 16, because it was considered 0, it will be 0, and then this will be, next one will be 16, then the next one will be 32, then 48, then 64, then 80, then 96. So these are all, this will be my first usable subnet, first subnetwork, then second subnetwork, and similarly the 14th subnetwork will be corresponding to this 14, that means 224.224. And the last one 1111, again all ones not usable. So this is not usable. Okay. So last, this is not usable, first one, then 14 used, then 16th one. So this is 0th was not usable, 16th is not usable because all ones are there, and in between the 14, these 14 are usable. Okay. And in each, if we consider the first subnetwork, then in each subnetwork there can be further 16 hosts. So within every subnetwork there can be 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 up to, out of which this 15 and dot 0 can't be used because all zeros and all ones cannot be used. So these are 14 usable addresses between 0.1 to 0.14. Okay, so this is how we can create a network and create subnetworks inside a network. So these are the range 1 to 14, because 0 and 15 cannot be used, and similarly 16 and 31 cannot be used, 32 and 47 can't be used, 64, because 64 is all zeros and 79 is all ones. So these are all zeros and these are all ones. These cannot be used. So remaining are this is the usable range. Okay. So this is how we can create subnetworks inside a network. So with this, we come to the end of this lecture. Thank you very much.